Okay, everyone, today I'm going to prove that the derivative of e to the x with respect to x is equal to e to the x, okay? Now, what is derivative? Derivative is differentiation, okay? So you're going to differentiate by doing over here. It's the derivative of f of x with respect to x. It's just a recap, is the limit as delta x goes to 0 of f to the x plus delta x minus f to the x, f of x, f of x plus delta x minus f of x divided by delta x. Okay, so this thing right here is the derivative of f of x. And there are some things too. What is e? Okay, when we're talking about this e is the limit, it's just a definition. So e is the limit of 1 plus 1 divided by n, all of this to the power of n as n approaches infinity, okay? And we have to assume one thing here, that n equals 1 divided by delta x. This is going to help us in the proof, okay? I'm just equating this to, I'm just saying that n equals 1 divided by delta x. You can just assume these things. Why? For example, as n approaches infinity, you have 1 divided by delta x with delta x approaching 0. Of course, that it cannot be 0 because you don't have 1 divided by 0. But when you have 1 divided by a very small number, okay, very small number, the result's going to be a huge number. So as delta x approaches 0, n approaches infinity. Since n equals 1 divided by delta x, right? As delta x approaches 0, 1 divided by delta x approaches infinity. And we're saying that 1 divided by delta x approaching infinity equals n. And n is approaching infinity. And over here in the e definition, n is approaching infinity. So one thing's tied to the other. Okay? All right. Now, making all these assumptions, we got to do the limit as delta x approaches 0, because that's the limit of differentiation, of f of x plus delta x. Now, what is f of x in the first place? It's e to the x. So we do e to the x plus delta x minus f of x, which is e to the x, this whole thing divided by delta x. Okay? Now, this thing right here, I always I want you guys, well, I'm just going to keep doing here till I run out of space. And when I run out of space, I'll just erase the whole board and just keep going. Okay. What is e to the x plus delta x? We can transform this into e to the, I'm just going to do it here. E to the x plus delta x equals e to the x times e to the delta x, right? Yes, because if you're multiplying something on the same base, you keep the base and you add the exponents, right? So since this equals these, okay, in this expression right here, what are you going to have? You're going to have minus e to the x. Well, you got e to the x in here and here, so you can factor it out. So that's what I'm going to do. This is going to be equals to e to the x factored out of e to the delta x, okay, minus 1 divided by delta x. I'm going to try to get this a little bit. Okay. So you can see that this thing right here is the same as that. Okay. They're the same. E to the x times e to the delta x is going to be e to the x plus delta x minus e to the x times 1 is minus e to the x. So it's just a different way of writing the same thing. Now, what are we going to do? When you have a limit multiplied by something else, by another limit, you can just split these limits together, okay? So this whole thing is going to be equal to the limit as delta x goes to 0 of e to the x times the limit as delta x goes to 0 of e to the delta x minus 1 divided by delta x. Okay, since we have a fraction in here, I decided to leave this e to the x alone. I split it over here, okay? And the delta x in here, I kept with this part right here. Okay, so what is the limit of e to the x as delta x approaches 0? Well, this e to the x doesn't depend on delta x, so it's just going to be e to the x, all right? So if we can prove that the limit of e to the delta x minus 1 divided by delta x as delta x approaches 0 goes to 1, if you can replace this whole thing in here, okay, by 1, it's going to be e to the x times 1, which is just e to the x, and we've proved it. Okay, so here's what I want to do. To prove this thing right here, to prove this part right here, okay, I'm going to have to prove that the limit of this stuff goes to 1. So that's what I'm going to do. I'm just going to erase this thing here. Erase it. I have to prove that this goes to 1. Okay, I have to prove that this goes to 1. I'm just going to put the separate in here. I can prove that this goes to 1, and I'm going to put a question mark, okay? Like, we don't know. That's what we're trying to find out. Okay, does it go to 1? Okay, so here's what I'm going to do. What is E? E is this stuff right here, okay? But we're assuming that, so you see what I'm going to do is transform. Instead of using n to define E, I'm going to use 1 divided by delta x, because we're saying that 1 divided by delta x is n. So E equals 1 plus 1 divided by n. 1 divided by n is going to be 1 divided by n is 1 divided by delta x, which is the same as 1 times, this is a fraction division. Okay, so the second fraction here, you multiply to its reciprocal. So it's going to be just delta x. Okay, so coming back in here, 1 plus 1 divided by n is just going to be 1 divided by delta x, which is just going to be what? Delta x. Okay, this n is actually 1 divided by delta x. Now, this part right here is not as n approaches infinity. Well, it is as n approaches infinity. As n approaches infinity, 1 divided by delta x also approaches infinity because they're the same. But how do you make 1 divided by delta x approach infinity? You make delta x approach 0. Okay? So you make delta x approach 0. Now, that is the new definition of n. Okay? And what we have here, we're saying that E is being elevated to delta x. So I'm going to erase this E here. Just going to erase this part. Okay? So I'm going to drag this thing here a little bit out of the way. So what do you have? E elevated to the delta x. Okay, so you're going to have to elevate this whole thing here to the delta x. Minus 1, okay? and this whole thing divided by delta x. Now, what are you going to be left with? Well, you see, you can multiply this exponent here to this exponent here. When you do that, this delta x cancels with this one. So this whole thing disappears. Doesn't matter anymore. Okay? You have a 1 here and a minus 1 here, so these two cancel out. Look at that. And you have delta x divided by delta x, so these two, they divide. So this whole thing here, what did it become? 1. Okay? You guys remember that I had to prove that the limit of delta x, this is what we had to prove right here, that the limit as delta x goes to 0, that e to the delta x minus 1 divided by delta x was going to be 1. Well, we've proved it, so now you can get this question mark out of here. This is true. Okay? So the limit, now thinking about this line right here again, the limit as delta x goes to 0 of e to the x, which is just e to the x, e to the delta x minus 1 divided by delta x. Well, this whole thing in here became 1. And there you go. So you have, now I'm going to continue this line over here, okay? It's this limit as delta x goes to 0 of what? Of e to the x, which is just e to the x. And there you go. It's proven.